I'm here with Alex Bachman, the designer of the Onedof turntable. Hi, Alex.
Hello, Peter.
We've had the turntable in the listening studio under review and analysis for 6 months. Alex, I wanted to ask you straight out, what made you want to design one of the world's best, if not the world's best turntable?
If it's not, I'll have to redesign it. I just wanted to hear the music as close to the original performance as possible. I know everybody says that, but I had to make my own shot, my own attempt.
You're relatively new to the audio industry, but not to industry itself. People can get on your website and see that you're a rocket scientist. You've helped re-engineer parts, repair parts to the Space Telescope Hubble. You've worked for NASA, you worked for Lockheed Martin, and you currently work for Boeing. You take a lot of experience into designing the turntable. What is the biggest challenge that you found in designing a turntable? It would seem very simple.
By the way, NASA was my client and I worked for NASA.
Okay.
One of the reasons is perfection, or attempt to achieve perfection as close as possible.
Mm-hmm.
Corporations are limited in perfectionism because they have to achieve schedule, and that limits innovation.
Mm-hmm.
I wanted to have conditions for unlimited innovation.
The turntable has a fit and finish that is most beautiful. We can see it, you've seen it in the videos, but it's not the look of it, it's really how it operates. What sets the design of your turntable apart from any other turntable that's currently available on the marketplace?
The bearing and controls.
And when you say the controls, do you mean the controls that control the motor, the speed of the motor, in concert with the bearing, or what do you mean by controls?
Right, the computer that operates motor.
Okay, okay. You were saying just a moment ago, before we came on camera, that the motor is a very expensive unit, a $400 unit. That the control itself, the hardware, was $1,000. Well, the turntable itself is a manufacturer suggested retail price of $150,000. And interestingly, you are selling the turntable direct to the consumer, asking for a 50% down payment. I can begin to see, just with the parts alone that you had to use to build the pieces to the turntable, outside of the engineering and machining for parts such as the bearing, partially some of the reasons why it costs so much. What really makes that turntable cost you so much to manufacture?
Complexity of the parts and the fact that I cannot order too many parts.
Mm-hmm.
I cannot sell more than a few turntable at a time, and it limits my ability to reduce the cost of manufacturing.
Turntables in this marketplace, in the top level marketplace in the world, can cost upwards of $650,000. Goldman has a turntable that's currently listing at $350,000. It seems like there is room, price-wise, for the turntable to reach up for the stars. Certainly the look of the turntable is of that quality and of that caliber.
So I'm reaching for the stars.
Very good, very good. Now the turntable, and I found this as I've been reviewing it, and you'll see in one of the videos, the torque on the turntable is unbelievable. You can have a turntable on at 45 RPM and put your hand on the side of it and try to slow it down. And then you push harder and harder and harder, and you realize that, my goodness gracious, the torque of this thing is beyond any other turntable I've ever used. Now, the torque has something to do with the bearing design and the control and the motor and the belts. Why don't you tell us a little bit about that?
There's enormous moment of inertia that the motor has to overcome in order to keep the velocity steady.
Mm-hmm.
That is why a motor is over-designed. The power of motor has enormous, I like the word enormous, power margin, so that it is acting fast and straightens out velocity if there is any distortion.
Mm-hmm. What made you design or decide upon a a three-pillar design and not use a plinth? Is there any reason for that?
Functionality, the best way to confine problems that occur during the operation is to make units separate.
So you've compartmentalized your challenges.
Right, but there is also another very important issue. I want to make this turntable last for generations.
Mm-hmm.
So the bearing is not wearing out, neither is the fluid inside the bearing.
Mm-hmm.
But the motor is going to be obsolete eventually.
Mm-hmm.
And I designed the control unit and the motor enclosure adjustable so that in the future more perfect motors can be used and more perfect controls, better computers, different electricity. It's instant. I mean, it's endlessly updatable and upgradable. So, and I will upgrade it during my lifetime, and I will make sure that people who are creating the company after me can do the same thing.
So it sounds like an investment in the future, that it's almost, in a way, future-proof?
It is not proof, probably, because we have to see the future before we can say it.
Right, okay.
But
Fair enough.
what makes it future-proof is that there are a couple of young people who really want to do it.
The turntable is certainly for music lovers, and as you'll see in the videos, and as you'll see in the conclusion, that I found the turntable to be the best looking and the best sounding turntable I've yet had in my system. The dynamics are explosive. They're not limited. The inner detail is immense. The image density is stupendous. The holographic imaging is frankly off the charts. It really is. You just want to go over, you want to look at it, but you want to use it. It's that compelling.
So anybody who has any questions, concerns, curiosity, should contact me directly, and I will always answer all questions from anybody.
Well, I want to thank you for your time today. The $150,000 turntable man, Mr. Alex Bachman from Denver, Colorado, who is indeed a rocket scientist, who has indeed built...
Rocket engineer.
I stand corrected, a rocket engineer. Thank you, Mr. Bachman.
Thank you, Mr. Bringer.